Hi, and welcome to this episode of Flavors of Cacao. You know that this is the website which has surveys running to understand a person or the general population's liking to different flavors of cocoa, um, which is the basis of the chocolates that we all eat. In fact, if you go to the website even today, you will find a survey running, and I do hope you will participate in that. Now, when I say we, I'm talking about Shreya and me. I'm Subhashini, and I'm very happy to bring to you the analysis on the survey. We've done the case study in Excel earlier, and I do hope you will go through those videos as before this so that you get the flow of what we are intending to do in Python. So, when we look at the survey analysis, we know that chocolate is one of the most popular eaten candies of the world, and especially in the United States nearly 3 billion pounds is consumed every year. Three things that we want to understand from this survey is where are the best cocoa beans grown, which countries produce the highest rated bars, and what's the relationship between cocoa solids percentage and the rating. With this intention, we start off the process with the six-step process I always follow, Dikova and I. In the define, we understand that there are the three questions which we mentioned earlier that we want to answer here. Which data practice will we really use? And the answer here is we're going to use cognitive analytics, which is basically visualization and reporting, because we really don't need a statistical model or a machine learning model for this project. There is no extra data. So in the collect phase, it's no data that we're trying to merge or join. In the organized phase, we find that there's hardly any missing values, no outliers in at least the y variable, which is the ratings, and dummy variable and derived variables are also very few. The visualized phase will see us looking at the visualization in terms of tables and reports and graphs and charts. Analysis, we will use the Pareto principle, frequency counts and cumulative frequency, but that's about all. And in the insights, we will try to answer and come out with the exact answer of the three questions. So with this, let's get started. So here we go. We've copy pasted the summary sheet outputs of the Excel project out here so that we have the flow that we wanted to follow in Python also. The first part of it is, of course, importing in the data set. And when we look at the head of the data set, we realize that the data has a lot of fields here, but some of them are not really relevant. So here is one ref. There's another called primary key. These don't seem to have any relevance to the three particular questions that are in mind. But anyway, there are 1795 rows and 9 columns. A describe function shows us that there are 4 primary numeric columns that we have, which is ref, review date, cocoa percent, and rating. And then we want to look at some missing values. Do we really have missing values? A simple function of is na dot sum sums up whichever values is na across the columns. And we find that there are 3 columns, the bean type, broad bean origin, and the primary key, which may have one value missing. So that's not too bad at all. Now, as an additional check, and sometimes, when you import in data from Excel or CSV, you may end up with some extra rows of data which have only NAs. So a good way to go about this is to drop NA on axis 1, and how only if all the columns have NA. So we do that, and when we look at the data again by doing is NA dot sum, what do we find? That we hardly have too many columns which could be dropped. Okay, uh, or too many rows either. Now, the first thing that we want to do is to understand that the bean type, what are the bean types and how many in terms of count and frequency exist. When we do this with the old fashioned method of doing value counts, we can see the outcome over here. Now, the question is this the only way to do it? And the answer over here is that before we go forward, one important thing to understand is that how come all the names are coming with this slash n in between? Now, what does this slash n mean? It means that the name is in two rows of data. So that's been in the first row, slash n shows it's in the next line. So that's been type, written been in the first row and type in the second. We don't want to do that because it's always a confusion. It's always difficult to pick up names which are longer. So one of the things we want to do is to rename. To do that, we would want to understand which are the column headers that are currently in the data set. And here we go. When we do column names and say to list, we get the list of headers. The next code over here is a rename code. Very simple. Just say df.rename, and the column, the old name, the one that's existing, is to the new name, the one that you want. Okay. And then look at the data set. So here I do df.info, and here you can see that all the names are looking so much better, very much better. Now, the other question that comes is, do we want to remove or drop any column? And I would want to drop this reference column. It's of no use in my opinion. So one good way to do it is to say that drop ref access is equal to columns, and then look at the data again. So what happens is the ref column gets dropped off. If you would want to maybe drop off review date or primary key, you can also do that. Go ahead and do that. In fact, practice the code a bit. The next piece to do is to see how we can make a frequency table without doing the old-fashioned value counts. So there is a new library within Pandas, which is called sidetable, and I can import in the sidetable library so that I can do anything related to frequencies very easily. Initially, when I tried doing it, it told me that this library wasn't installed on my system. So I did a pip install sidetable and went ahead with using sidetable. So what is the best advantage? It is that I can do the Pareto analysis very easily. Now, you will remember that when we are looking at decision making, we want to focus on the most important elements, and Pareto is a great way to figure out which are the most important elements. The ones which look at 80% of the values are the most important. The remaining 20% are the least important. So let's look at it. We just did company location frequency with the threshold of 80. And we have said that label all the other company locations as others. And that's what this data command has done. This is what the site table has done. It has got all the major countries which created the chocolate, okay, and clubbed everything else into others. Okay, you can look up site table very easily. It's available in the Pandas library. It's available on Google. Go ahead and look it up. It's a relatively new library. Now, of course, one of the things to do is to save all this data into a different table so that we can custom sort it. Like here, I have done and created a table one by looking at the frequency of cocoa percentage, and so that I can sort it on cocoa percent, because the default sort is on the cumulative frequency. Now, when I do this, what do I find? That, I want to actually club cocoa percentage into smaller values, because what is the percentage looking like? 0.42, 0.46, 0.6, 0.7 up till 100%. So we have really light chocolate to very, very dark 100% chocolate. Okay. So what do we want to do? We want to club it on the quantity of chocolate in that particular bar. And one way to do it is to create a list of bins that I want to have. Here, I want to have bin of less than 60, 60 to 70, 70 to 80, and then greater than 80. I have put the bins together, I put the labels together, and then created the given the command to create the category, cocoa category, which is the new variable, which is based on cocoa percentage being binned. Okay. Now here you will notice a part of the command says write is equal to false. What exactly is this? it means that the intervals are closed on the left side and open on the right side. Okay, so a value falls into a bin if it is greater than or equal to the left side, which is 60 here, 60 to 70, if it is greater than equal to 60. Okay, uh, and less than or equal to the right endpoint. Okay, so a value will actually come in between 60 to 70, then 70 will not be available for 70 to 80. So let's go ahead and see how the new data point looks like. It's called COCO category, and we can see greater than 80, 70 to 80, etc. Right, that's how we wanted it. Now what do we want to do? We actually want to now run a frequency of how many values in each of these segments. Okay. Now, the question that comes to me is often that in this particular library, can I use it to find out missing values? And yes, we can, because it does do a frequency count, right? So here you go. We check out the new data frame, use STB, the library, and look out missing values. Okay. Now let's look at the count of ratings, and the average of ratings. So here because it's not frequency, this particular library side table will not help. We have to go back to the old way of doing it, which is first do the count and then calculate the average. So what do? We create stats is equal to a count of ratings by company location, and then we create mean rating, which is the same as the sum of ratings divided by count of ratings. Okay, because we want all of this in a combined table, we do a combined table and do a PD merge, okay, on company location. So here in this table we get company location, count of rating, and the mean rating, right? But we can see that there are just so many countries out here. So what do we want to do is to actually create the Pareto analysis. Now here we don't have things handed out to us, so we have to go the old fashioned way, which is first we sort the combined table by count of rating in descending order. Then we calculate the cumulative frequency column and identify the threshold of Pareto, which is 80%. Finally, we filter the rows based on the threshold and display only the values which total up to 80%, the top 80%. Okay. So let's go and see. Here are the top 80% of the values. How is this done? It's done on the descending sort of the count of rating. Okay, so these are the values that we want to consider. Now here, when we are looking at this, we would also want to make a type of graphical representation, for which we look at matplotlib and pyplot as a function of matplotlib library. We bring it in and we create a plot, okay, in which we want to create the cumulative frequency line also. So here you go. I hope you can see it easily. This is the plot of the values, but also you can see the cumulative frequency line, right? This red line. So it tells you that these countries actually form a majority of the values. Now, can we use the codes we have created above to answer the three questions? Let's try with one of the questions. Which countries produce the highest rated bars? So I've got the Pareto analysis, the set of countries which fall within the Pareto analysis, and I take that set of countries and that table created, and I sort it on the mean rating. Okay. So what do? I sort it on the mean rating. Ascending is equal to false. That means descending with the largest mean rating on top. Hence, what do I get here? I get the top three countries by mean rating are Australia, Switzerland, and Italy. If I was to look at the five countries, it would be Australia, Switzerland, Italy, Canada, and France. Okay. Now I will take a break at this point and request you to answer the remaining two questions using a similar methodology. Reach out to me if you have any doubts. Do remember the 6-step process of Dekova and I. I find it extremely useful in doing any type of project. Thank you.